Okay, so next we're going to solve for a per unit tax. And so to do that, we need to use some intuition. So the first thing that we want to do is realize that when we impose a per unit tax, it reduces the amount traded in the marketplace. Something less than 700 is what we expect to see. We know, because we've lived in this world, that the price consumers pay is going to be higher than what they would pay if there was no tax, and the price suppliers receive is going to be less. So we're talking about the coffee market here. Now I need to create a mathematical expression to represent this wedge equation, and so PD equals PS, the sticker price on the good, plus the per unit tax is how much consumers pay. And so step one is going to be to find the QD prime that considers the tax. So we're going to insert, I see a PD here and a PD here. We're going to insert PS plus T and get this function for QD that considers the tax, okay? So I'm going to distribute the negative 200, and I end up getting the following equation for QD prime. I'm now going to set QD prime equal to QS. PS. Okay, so I'm just going to combine the PS's by adding 200 PS, and I get 900 PS is equal to 900 minus 200T. I'm going to divide both sides by 900, and what I get is something really logical, and in my class we call this liquid gold, okay? So I'm going to box it, start it, and refer back to it. What this says is that the price suppliers receive when there's a per unit tax fluctuates around the free market price of $1. It's reduced, it's lower, and they only pay 2/9 of the tax. That's exactly logical because they have a whole lot, producers have a whole lot more options. It's a more elastic curve. Okay? Let's use logic to produce the PD, how consumers are affected by the tax. Again, we fluctuate around the free market price. We pay more, not less. If 2/9 is paid by the producer, then 7/9 is what is left to pay, and that is what consumers must pay because they have less options in the marketplace. And finally, I have to find how Q, the quantity traded in the marketplace, fluctuates with the existence of the tax. So my choices are either to take the equation for PD or PS and plug it in. And so because we've been consistently plugging into demand, we'll do that one more time. So I'll say that 900 minus 200, and then I'll take the equation for PD, which is in blue here, 1 plus 7/9 T. I'll distribute the 200, and what I end up getting is the quantity traded with the tax is equal to 900 minus 200, 200 times 1, minus, this is something like 155.55 T. And so I'm going to reduce, and I get the quantity traded under the tax fluctuates around the free market price of 700, and it's reduced by some multiplier of that tax. And so again, another really important equation. And now, anywhere I see a T, here, here, and here, I just plug in the per unit tax I want to analyze. So if I want to analyze a tax of $1, I plug in $1 anywhere I see a T. If I want to analyze a tax of $2, I plug in $2 anywhere I see a T. And in this case, what I find for the $1 tax is that consumers pay $1.78, producers pay 78 cents, and the quantity traded in the marketplace is $544 units. And this is exactly what we predict. The difference between the two is $1. It's reduced the marketplace from the 700 units traded. And so for a lot of reasons, I believe that this is true. And this is a great tool for you to solve for taxes using the wedge quotient.